Okay, now let's start some questions based on points of intersection of normal with the axis of hyperbola. Here we have a question: if normal to this hyperbola meets axis at Q and R, then find the locus of midpoint of QR. Let's draw the diagram. We have a graph of hyperbola. This hyperbola. We have point P theta on hyperbola having coordinates A secant theta, B tan theta. We draw normal to hyperbola at point P, which meets axis at Q and R. Q is on transverse axis, R is on conjugate axis. Then we have to find locus of midpoint of QR. Suppose midpoint of QR is point T having coordinates H comma K. हमें point T का locus निकालना है, locus का equation निकालना है. कैसे निकालेंगे? We first find coordinates of points Q and R. Equation of normal at point P is this. We have standard equation of normal. Okay. In this equation, we put a square b square is equal to a square e square. For this hyperbola, we have a square b square is equal to a square e square. So equation of normal is ax upon secant theta plus by upon tan theta is equal to a square e square. For point Q, we put here y is equal to 0. We get x is equal to a e square secant theta. Together, this is value of x. This is abscissa of point Q. Okay, so coordinates of point Q are a e square secant theta comma 0. For point R, we put x is equal to 0. We get y is equal to a square e square upon b multiplied by tan theta. This is ordinate of point R. So coordinates of point R will be 0 comma a square e square upon b multiplied by tan theta. Okay. Now HK is midpoint of QR. So we have 2h is equal to a e square secant theta and 2k is equal to a square e square upon b tan theta. We have to find locus of point T. That means we have to get relation between h and k. So what we do? We will eliminate theta. हम जो वेरिएबल अवेलेबल है उसको एलिमिनेट करेंगे. We will use identity secant square theta minus tan square theta is equal to 1. Okay. Put the values of secant theta and tan theta from these two equations. We get relation 4h square over a square e power 4 minus 4 k square over a power 4 e power 4 b square is equal to 1. Okay. Now replace h and k by x and y. We get equation of locus as 4x square over a square e power 4 minus 4y square over a power 4 e power 4 divided by b square. This is equal to 1. This is equation of locus of point T, which is midpoint of QR. Okay. And this equation represents hyperbola. तो यहाँ पे point T का locus भी hyperbola होगा. Okay. Then with this question, normal to this hyperbola at point P meets transverse axis at Q. If f1q upon f1p is 6, then find the eccentricity of hyperbola. We have point P on the hyperbola. Coordinates of point P are a secant theta, b tan theta. Normal at point P meets transverse axis at Q. Okay. We have coordinates of Q. हमने अभी निकाले थे. Coordinates of Q are a e square secant theta comma 0. Okay. F1 is this focus having coordinates a comma 0. Now this ratio is given. Then we have to find the eccentricity. It's simple. What is F1q? F1q is a e square secant theta minus a. Okay. So this is ae multiplied by inside bracket e secant theta minus 1. Okay. Then what will be f1p? We can use distance formula or we can use the definition of hyperbola. Okay. We consider this directrix x is equal to a upon e. From point P we draw perpendicular to this directrix. meeting it at point M, then from definition of hyperbola we have f1p upon pm is equal to E. Okay, so we have f1p is equal to E multiplied by pm, and pm is a secant theta minus a upon E. ये होगा ना, ठीक है. We take E inside and take A outside, we get A multiplied by E secant theta minus 1. Okay, now put the values of f1p and f1q here. Okay, we get E is equal to 6. Eccentricity of hyperbola is 6. तो एक सिंपल क्वेश्चन है, अगर आप इसको टेक्निकली हैंडल करते हैं, वी आर नॉट यूजिंग डिस्टेंस फार्मूला फॉर f1p, वी आर यूजिंग डेफिनेशन ऑफ हाइपरबोला. ठीक है, उससे हमारा एक काम आसान हो रहा है, हमारे कैलकुलेशंस कम हो रहे हैं यहाँ पे.